Hi, welcome to the second part of Design of Concrete Elements using STAAD.Pro Connect Edition. My name is Surajit Ghosh, and in this video, I'll discuss how we can design and generate drawing files of various concrete elements like beam, column, and shear wall of a 15-story building structure modeled in STAAD. Before that, to get a general overview of STAAD Advanced Concrete Design module, please watch the first part of this series. Let's check how to perform design, generate drawing files, and design reports in advanced concrete design mode. I am going to use this 15-story building structure to demonstrate some of the features of this concrete design module. This model is generated using building planner mode by specifying different floor plan at different levels. All these plans are internally stitched together to create the 3D structural model. Shear wall is created with parametric model option, and for this I have selected the type as wall. Only if the plate mesh is created using parametric model wall option, then only RCDC can read the analysis results and design it as a wall. I have already applied all the loads including dead, live, seismic and wind loads, created the combination cases and analyzed the model. So all member forces are available, and now I am ready to design the members using Advanced Concrete Design mode. STAAD Advanced license is selected as I want to use all features of RCDC including tank design module. First, I want to design the column and shear wall present in this model. Note that you need to select the design code from this job window, and this cannot be modified later. All design parameters, design checks, and generated load combination cases are dependent on this selected code. I want to use ACI 31814 code to design the columns. See, all model information, member properties, load data, force values are imported from the STAAD model. This information will be used for concrete design. Once the model is imported, you can find the column layout plan along with the level information. As you can see in the general layout, all column and the central shear code is imported in RCDC. From these tables, you can further check the member information, or you can also modify it. Say I want to use 500 grade of steel for all columns. I can modify it directly in this table, or I can change any column dimension or convert it to a flanged column like T, L, or any polygonal shaped column by specifying the dimensions. Anything changed in this module can be exported back to STAAD for analysis. I'll show this later. You can also specify the framing type of columns. By default, it is selected as non-ductile, which means all these columns can carry both gravity and lateral loads. But when you perform ductile design, you can select proper framing system from this table, and program performs the ductile detailing based on IS 13920 or ACI 318 code. To account different framing system in analysis model, you can assign member release command along with the change command instead to ensure proper load transfer through different framing system. From design settings option, you can define all the code specific design parameters, and it varies depending on the selected design code. For ACI and IS codes, the design parameters are more or less similar. You can specify whether you want to perform ductile design or not, and also need to provide the response modification coefficient or response reduction factor. Live load reduction can also be specified level-wise. Effective length factors are calculated automatically considering the sway non-sway condition, and if you want, you can further edit this value. You can also optimize the design as mentioned earlier. Crack width check can be performed based on ACI 224 or IRS code during member design But for this, you need the advanced license. From reinforcement settings, percentage of steel, max min bar dia, types of link and spacing can be specified. Detailing and drawing settings are also available, which controls the drawing file generation and bar arrangement. All load cases are imported from STAAD. You can further import the combination or repeat load cases either from analysis model or directly add the combination cases based on the combination factors specified in relevant design code. Once all parameters are specified, you can perform design. Design is first, it doesn't take much time. A table with all reinforcement details is generated, and if there is any failed member, that is displayed on screen. We can further check this failure in the table marked in red color. To check the failure reason, we can go to failure diagnostic report. The reason along with the load case number and percentage of steel is reported here. For this model, most of the columns fail in detailing or steel percentage crossed 4% limit. For column 1, the failure reason is detailing with a steel percentage below 4%. This means program is unable to arrange the maximum dia bar due to spacing criteria. So we can increase the section size to eliminate the detailing issue as well as decrease the steel percentage. Simply select the failed segment, redesign the section. I can also increase the grade of concrete and redesign to check if it passes. It is not. Increasing the section size to 400 by 400 solves the problem, and if I accept, design results are reported in the table with this change. For column 3, different levels fail, so it is better to change the overall column dimension. Changing the column size as a whole to 400 mm square section, and now it passes. We can also change the shape to flange column like L or T column if required. Shear wall design is performed along with the column design based on the design inputs. If the shear walls are not interconnected, then they are designed as an individual wall element. But if they are connected, like this case, then the reinforcements are determined for a combined wall. So at the corner where two walls are connected, combined action is considered, and accordingly reinforcement bars are provided as you can see in this picture. One good advantage of RCDC is this type of visualization. We can check the cross-section view for any column section or shear wall anytime, or we can also change the link arrangement graphically. If you are not satisfied with the link arrangement, simply modify it by selecting the desired link. Note that if you change the links manually, program does not redesign the links and it might be unsafe. Option to copy paste the reinforcement or grouping of similar columns are also available. Apart from this, a detailed drawing can also be generated. For example, I want to generate the drawing for this combined wall. Select the wall and drawing file is generated, which we can save as DXF file. See how detailed the drawing file is. All reinforcement details are provided here. Similarly, we can generate the elevation drawing for column and wall. You can save this file and then open in any CAD software to further edit it or insert your custom template. That's all. Along with the structural drawing, a detailed calculation sheet is also generated. All relevant clause, critical force values, intermediate checks are reported for all members, including the actual analytical member information. So if you want, you can cross-check the force values with your STAAD model. Bill of quantities can also be generated directly from here in any currency of your choice. You can select the type of BOQ that you want to generate, and depending on the design results, the BOQ file is generated. And finally, the most advanced option, generation of the BBS file. Once the design is complete, you can generate the bar bending schedule file for any member. It is very detailed. All bar mark, cutting and bending length, dimension along with the schematic diagram is reported in this file. And whenever the design is modified, this file is auto-updated. You don't have to change anything. Now, I have changed few column size, which I can check directly from the size change report. Original size and the modified size information is reported in this file. You don't have to remember this change. If you want to update your analysis file based on this, simply click on Update Analysis File option and a new model is generated with all this section change update. You can further analyze that model and update the design results based on the modified forces. For beam design, everything is almost similar to column design. You can design a typical floor beam, or you can also select multiple similar floors, and program will sort the highest force values for design. As mentioned earlier, program automatically forms the physical member depending on the beam connectivity. You can further edit it, split the member or merge any member to the nearest physical member. In design settings window, you can select your preference for torsion design or ductile detailing. Also, you can convert the beam to a flanged beam like a L or T beam where the contribution of the slab area is considered when bending is at the bottom. Thickness of the slab can be entered manually or imported from the slab design file. You can also design a beam for combined axial and bending forces. If the axial force in the beam is considerably high, you can consider that axial force for beam design. There are also multiple reinforcement bar arrangement like best fit where the bar dia is optimized, or max and min dia option where same dia bar is provided throughout the span of the beam. Crack width check can also be performed. Rest of the reinforcement settings or drawing settings are same like column, so I am not going to discuss that. Once the beam design is complete, a detailed tabular format output is provided with all bar details, including side face reinforcement information wherever required. Further, you can generate elevation and sectional drawing files. Say for this physical member, I want to generate the drawing file. I can select what information needs to be printed, and elevation of the complete physical member is generated with all the marking and cross-section diagram. See how detailed it is with all bar arrangement, cutting length and marking. Every information is provided in this drawing file. We can also generate the detailed calculation sheet just like column. All design force information, critical clause and intermediate calculation steps are reported there. And finally, bar bending schedule file can also be generated. It can be generated for a single member or for all the members present in the model. Using this file, you can actually eliminate the requirement of sending the data to the draftsman, and as this is automated, there is no chance of any human error. In similar way, we can perform design of slabs using panel method and generate the drawing files as well as detailed calculation sheet. Note that all slab panels and interconnections are determined from the STAAD model, and this can be further modified, but no finite element analysis is performed for this. A drawing file for staircase with reinforcement information can also be generated, but it is limited to dogleg staircase only. I am not going to cover the foundation design part as we have planned for a separate session on foundation design and slab design based on finite element analysis. Stay tuned for more update on our upcoming webinar series. Thanks for watching.